Okay, so last time we were talking about joins, and in general, we were talking about the generalized join operation that we called the theta join. So the theta join was where we can specify certain conditions. So in general, joins are always going to, by default, where in at least in relational algebra, where um, join operations where we actually looked at the similar column names and we always joined based on that. So an example for an inner join or a natural inner join was just select star from borrower inner join. However, we can also specify conditions to our join operations as well using the on operator. Right, so everyone remembers that. So the on operator allows us to give us any conditions that we want, and it doesn't have to be an equality condition. It could be any other condition such as inequality or less than, greater than, what have you. So we can have a join operation that can take any predicate, not just the equality predicate, right? So essentially we can specify the join that we want using the on condition, and we can then specify whether it's an inner, outer, full outer, left outer, those sort of joins, right? So inner join is going to be the default join operation, so you can just ignore that, or you can specify whether your join is an inner join or an outer join. Usually you specify something's an inner join where, for example, you want to make an inner join for the first two tables and make an outer join with the another table with the result of that. So when you are using multiple join operations and they have different behaviors, you would specify whether it's an inner join or not. Other than that, it's optional if you just use it as a standalone join operation. Give me one. Pranay, can we talk about that after the class maybe? Would you remind
Sure,
me?
Professor.
Okay. So essentially those were your join operations, and so we had that on clause where we were using the on clause to condition our join operations into different conditions. And you would remember that the on clause takes a predicate and performs the select operations based on that predicate, right? So that in a sense also looks similar to the where clause. And we talked about how those two operations are the same, but in general, just as a good programming practice, you should always use the on clause for join conditions and the where clause for selecting rows by default. So there are many, so including this join operation or this theta join operation allows us to write the same thing in different ways. All of those ways are same, but that is, I mean, so that also means that basically that one particular solution might have different ways of writing it, and that is something that MySQL does allow, or any SQL language allows. So for example, select star from borrower cross join loan would get us the complete list of all possible combinations from borrower and loan. We can also set the on predicate to be always true and perform an inner join on true. That means that for all possible conditions, this is true. So this also ends up being a Cartesian product. And we can also say select star from borrower comma loan. That also results in the same exact thing. Okay.
So real quick, the on true thing,
Mhm.
is it just checking if the field is filled and not null, or is it checking something else, like an
So
actual true value?
it's checking nothing. So imagine the case where we have if true, do this.
Mm-hmm.
So in that situation, does it do anything? It won't do anything, right? It is basically always going to do that.
Right.
So
Yeah.
on true basically means that, like, I don't have any condition whatsoever. I say that it's an inner join, but since it's an on true, basically it becomes a cross product or a Cartesian product.
Okay, that makes sense then.
Okay. Any other questions? So we can also, in terms of Outer joins, we can also specify left outer join, right outer join. I mean, we would have to say left outer join, right outer join, or full outer join. We can also say that it is directly left join or right join or full join. And we can just skip out writing outer altogether, because left, right, and outer are always going to be, left, right, and full are always going to be outer joins, right? Okay. What else was there? Another simplified form was the using clause. Using clauses were pretty much the same thing as with on clauses, but you are basically specifying the equality constraints on certain attributes. So the using clause only allows equality constraints, not any other constraints. But we can say that for select star from T1, left outer join T2, using A1, A2, and so on. So that basically means that A1, so T1.A1, T2.A1 has to be the same, T1.A2, T2.A2 has to be the same, and so on, right? Okay. Inner is optional, blah, blah, blah. Okay. So if we perform a join operation such as this, say select star from borrower natural join loan, that means that we are basically performing a natural join across two tables, that is the borrower table and the loan table. And if we remember the natural join condition, it will figure out the common attributes between those two tables and join them based on equality conditions on those two tables. So here we do not have any on clause, so there is no condition there. So essentially the common attribute for those two tables were the loan number. And so according to loan number, both of those tables are joined together. And because of that, the common attribute gets to be the first attribute in your schema, followed by that all the attributes in your borrower field, followed by that all the attributes in your loan field, right? We can also write the same thing just by saying that select star from borrower join loan, just join. So that means in a join loan using loan number. So basically that also means the same thing as performing a natural join. Okay. So in general, natural joins can be, so we have a natural, we can also have something called a natural outer join. So remember that up to now we have talked about natural joins being the same as inner joins, but in SQL we can also have a natural outer join, and this is something where usually students find this a bit more complicated. So we can say that something is a natural outer join or natural left outer join and things like that. So just remember that when we say outer joins, so essentially inner join, left join, right join, or full outer join, these are all cases where essentially you are saying what to do when we have unmatched rows. So remember when we talked about left outer join and right outer join, if we perform the left outer join for all those rows where the rightmost table did not have entries for those, we filled those out with null values, right? And vice versa for right outer joins, and both of those cases for the full outer join. So in general, inner join, right outer join, left, right, and full outer joins are all the cases where we are deciding what to do when we don't have values for the result. So essentially include null where. And on the other hand, a natural join is the natural keyword is more similar to the using or on keyword, where we are actually specifying the condition. So when we say a natural join, we are saying that the attribute names should be the same, right? And those attribute names would be used to join the tables. So natural, using, on, these are sort of orthogonal to what you have as full, left, right, and inner join. So those select, those state what to do when I have unmatched rows and where to put those null values. On the other hand, natural, using, and on specify the conditions for joining two or more tables. So this is something that you need to make understand very clearly, the difference between these two sort of things. One is where to put the null padded values, and the other is what to use as a condition to actually join those two values. Okay, give me one sec. Okay, so so as I said, outer joins can generate null values. And again, I'm going to harp on back to this point again and again. Aggregate functions will ignore null values all the time. So sum, man, max, min, and all of those things. But count has this special capability that if it sees a null value, it would return a zero. Right, so count is the only aggregate operation that behaves like this in terms of null values. So for example, if we wanted to say find out how many loans each customer has, then we would basically try to join the two tables, customer and borrower, and then figure out if any customer has null values for their loan IDs. And if there is a null value for the loan IDs, in that scenario, we would say that the count of that would result in a zero, and we would say that that person has zero loans or more than that. So essentially, if we join customer and borrower, we would actually want to have a we would actually want to have a left outer join in this case. So essentially customer left outer join borrower. So for all entries for which borrower does not have a corresponding customer, that means that, I mean, customer does not have a corresponding borrower for that one. So those loan values would become null. And then we can perform a count operation to get the number of loans per customer. And for those customers that don't have a corresponding borrower entry, those values will become null. And now that we have that, we can actually count all the loans, and then it would give us the number of loans for each customer, right? So this would be an example for this. For example, select customer name, comma, loan number from those tables from customer left outer join borrower. We did customer left outer join borrower, and we said that using customer name. So basically this was the on clause that says customer.customer name equals borrower.customer name, right? So we just said using customer name as a common attribute, and that joined this entire table. And this would look something like this, where we would have customer name and loan number and Adam Brooks and blah, 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 and their corresponding loan IDs. And a person can have multiple loans, and then Adams would have duplicate results, or Brooks would have, so Brooks is null, Cuddy would have duplicate results, duplicate customer names for different loan numbers. And if a person has no entry in the corresponding borrower table, that ends up being null, right? So everyone understands this, what's going on here, that we get a null value here because there is no loan for the particular customer. For example, Glenn or Green do not have any loans. However, Adams currently has a single loan. However, Adams could technically have more than one loan. So if Adams had 10 loans, it would repeat Adams 10 times with all of those corresponding loan numbers, right? Okay, and the other thing is, note that this current result, and even if you try this in MySQL, this current result is ordered in the customer name field, and it is all ordered alphabetically. But remember that this is something that your database implements. Up to now, we have not made any claims about the order of the general result. We can order them if we want, but we cannot claim that these results will be ordered like this. So different databases can have different implementations. MySQL would in general give you these in an ordered